What you're seeing is a neutron star, and Earth is being sucked straight into it. You can't clearly see it yet. It's only the size of a city, but the horizon is glowing. Air pressure is plummeting. What happens to the air you breathe as we're pulled closer? What happens to the ground when we arrive? And is there any bunker deep enough to keep you alive? This is what happens when Earth gets sucked into a neutron star. Before we go further, you need to understand exactly what is dragging us into the dark. First off, this thing used to be a star, bigger than our sun. For millions of years it burned through the periodic table. Hydrogen, helium, carbon, all the way up. Silicon to iron in a single day, then nothing. Iron can't be fused. The fusion stops, and in the silence that follows, the entire core collapses. An iron ball the size of Earth becomes a ball of pure nuclear matter the size of a city. In milliseconds, the explosion outshines entire galaxies. What's left is 12 miles across, but it packs up to twice the mass of our entire sun. So dense that a single teaspoon weighs 1 billion tons, meaning if you filled a large travel mug with this stuff, you'd be holding the entire weight of Mount Everest. Gravity 200 billion times stronger than what's holding you down right now. Inside, matter is crushed so hard, it forms structures physicists call nuclear pasta, stronger than anything else in the known universe. It's the most extreme object that exists without being a black hole. And Earth wandered right into its gravity well. We are falling. Stage 1 doesn't start with impact. It starts with a pulse. As a neutron star rotates, it fires focused beams of radiation from its magnetic poles. Not scattered light, focused beams, locked to the spin. Hundreds of times per second. Earth's magnetic field has shielded every living thing on this planet for 4 billion years. Against solar flares, against cosmic radiation, against everything the universe has thrown at us. But this thing's magnetic field, well, a quadrillion times stronger. Ours doesn't register. Every millisecond, that beam sweeps through Earth. Each pass strips another layer of atmosphere, ionizes it, and blasts it off into space. The air you're breathing right now starts thinning from the top down. Not over decades, over hours. The oceans don't boil. They get ripped off the surface as superheated plasma. Bye-bye, Pacific. The surface temperature climbs to levels that make our sun look mild. Toasty. Surface life ends right here. Not gradually. Between one sweep and the next, underground is the only option. But there's no going underground to escape what comes next. Because what comes next doesn't happen to Earth. It happens to the space Earth is sitting in. The neutron star hasn't touched us yet. It doesn't need to. It's already done something to the space around us that can't be undone. Einstein predicted something that even he found unsettling. A massive object that rotates doesn't just sit in space, it drags space with it. Physically, like a spoon stirring honey, except the honey is the fabric of space-time, and the spoon has been spinning since before our solar system formed. This is called frame dragging, the Lenz-Thirring effect. NASA confirmed it in 2011 with a satellite called Gravity Probe B, built for this one purpose. Here's what that means for Earth. Right now, we cannot move in a straight line. Not because of gravity pulling us in, we've had that for a while, but because the geometry of the space we're sitting in has been physically restructured by the neutron star's rotation. Fire a rocket directly away from it, the rocket curves. Try to hold a fixed orbit, the orbit twists. Every direction has been pre-bent. A rotating neutron star literally drags the structure of the universe behind it. If Earth is close enough, we can't go straight. The spin warps our path, forces us into a spiral, whether we want to or not. Not a force you'd feel, just every direction you try to go quietly bending away. Rotation, at this scale, is no longer motion. It's a control system for the shape of existence itself. Kind of a buzzkill for your escape plans, am I right? So, if a neutron star can restructure the geometry of reality around it, can it do this forever? Spin faster and faster? With no limit? No. There's a breaking point. And here's what's disturbing. That breaking point doesn't protect Earth. It protects the neutron star. Yeah, nature built a kill switch into the laws of physics. It just wasn't designed with us in mind. Rotation has a structural limit. Spin a neutron star too fast, and centrifugal force at its equator exceeds the gravity holding it together. It tears itself apart, back into gas and particles. 1 billion tons per teaspoon, just shreds into nothing. In a jiff, the fastest spinning neutron star on record, what astronomers call a pulsar, rotates 716 times per second. Right against that limit. Now here's the part that should bother you. Your first instinct, good. There's a limit. A kill switch. Something stops this from going on forever. You're right. For the neutron star. The neutron star is protected from spinning too fast. Earth has no equivalent protection from getting sucked too close. The universe wrote a rule that keeps the neutron star intact. It wrote no rule for what happens to the neighborhood. If that sounds like the rules were written by someone who wasn't thinking about us, they weren't. Atmosphere, gone. Space, warped. Kill switch, not for us. And we're still spiraling in. At roughly 400,000 miles out, something begins happening to the planet itself. Something with a name. And that name is somehow both scientifically accurate and the darkest joke in astrophysics. It's called spaghettification. And I promise, it's exactly as bad as it sounds. And then, considerably worse. Here's what happens. At roughly 400,000 miles away, the gravitational pull becomes deeply uneven. The difference between the side of Earth facing the star and the side facing away is now catastrophic. The Moon creates tides, a gentle, predictable difference in pull across 8,000 miles of planet. It gives us nice waves for surfing. This is 200 billion times stronger than Earth's own gravity, pulling the near side orders of magnitude harder than the far side. Earth deforms, stretches toward the neutron star, compresses perpendicular, an egg, then a teardrop, then a strand. The crust fractures. Not one fault line, all of them, simultaneously. Every volcano on Earth erupts in the same moment. To add insult to injury, the oceans don't boil. They get ripped off as plasma. The iron core, 4,000 miles of compressed metal sitting at the center of this planet since it formed, separates from the mantle, like pulling a yoke through a straw. Ouch. Every mountain, every ocean, every city, sorted by density, drawn into a flat ring of glowing debris spiraling around the neutron star. What remains hits the surface at 100,000 miles per second. The energy released dwarfs the combined nuclear arsenal of every country on Earth by orders of magnitude. Earth doesn't explode. It doesn't gracefully go dark. It gets digested, down to the last atom. That's not destruction. That's digestion. Good news, and I'm choosing those words carefully. The nearest neutron star is several hundred light years away. But none of it was theoretical either. Frame dragging was confirmed by NASA in 2011. In 2019, astronomers watched a star get torn apart by a compact object in real time. The light curve matched the spaghettification equations exactly. We didn't theorize it, we watched it. The same math governs your GPS. Your phone corrects for general relativity every single day, or the map drifts by miles. Same equations. The neutron star just runs them at a scale Earth has no answer for. It doesn't know we exist. It doesn't weigh 4 billion years of human history against anything. It just rigidly follows rules, written into the structure of the universe long before any of this was here. To build the atoms that made Earth in the first place, stars didn't just have to die. They had to die twice. One more thing before you go. What happens when two neutron stars find each other? They spiral inward, pulled together, the same way Earth just spiraled in. Except both objects are neutron stars, both spinning, both warping the space around them simultaneously. And when they finally collide, in a fraction of a millisecond, something no one expected starts happening. They make gold. More gold than has ever existed on Earth, forged in a single collision, a kilonova. Every piece of gold you've ever worn, your wedding ring, your watch, any chain you've owned, was made in exactly this kind of collision, billions of years before Earth existed. The terrifying thing that just digested our entire planet with the right partner in the exact right moment built part of you. How does the most violent event in the universe produce something as quiet and beautiful as gold? That's next. If you made it this far, do yourself a solid. Drop a like and hit subscribe. It keeps the lab running. The universe has laws, but we're here to push them to the breaking point. I'm Rabo, and the lab is always open. Catch you on the next one.